Start with transformers, and because that's something that is useful today. And then if you don't understand something, then look up this part that you don't understand. And then it's kind of reversing. I call it reverse learning. It's kind of reversing the path. You start from the things that are useful, and whatever you don't understand, go back. And then what happens is eventually you're going to reverse the path. You're going to learn the original concepts as well. But you gain a lot of time, because from day one you are working with the things that are useful today.
All right, so hello everyone, and welcome to the AI Stories podcast. I'm Leiser, I'm a data scientist at iWaka, and I will be your host. We bring together some of the best data scientists, ML engineers, and tech leaders to talk about AI and talk about their career. So today our guest is Miguel Fierro. Miguel first studied electrical engineering and then did a master in robotics at Universidad Carlos III de Madrid. And after that, he actually did a PhD at King's College London. During his PhD, he launched 2 startups, but in 2016, he actually moves and joins Microsoft, where he's currently a lead data scientist in the personalization team. So if you enjoy the episodes, subscribe to the AI Stories YouTube channel and leave a 5-star review. Alright, so let's start now. Hi Miguel, how is it going? How are you today?
Hey, Neil, super happy to be here. Really good. Yeah, and super interested in listening to what you have to ask.
Yeah, me too. Looking forward to this conversation. First thing I want to ask is just how did you get into this world of AI and machine learning? I know you started with electrical engineering, so how did you move to this world of AI?
Well, the short answer to that is that I made a mistake. I should have never gone to electrical engineering. So what happened is that I was when I was at school, and I had to choose a degree. I chose a degree that is called industrial engineering in Spain. And industrial engineering is something that it has a lot of tradition here, and it's kind of a mixture of all engineers together, right? So we have things about civil engineering, telecom engineering, electronics, mechanics, business, computing. It was kind of like everything, right? And it was very good if you didn't have any idea what to do, right? Like I knew that I liked math. I knew that I liked physics and engineering, but I didn't know what I really wanted to do with my life. So I went to this degree, and it was a degree of 5 years. It's full 5 years. It's kind of the same as the old in Grand École in France, and I think in other countries like Germany and Italy, it was kind of the same idea, right? And then in the third year, you had to specialize, and there was different options. Like there was electricity, mechanics, energy, business, and electronics and robotics, right? So I didn't know whether to do electronics or electricity, and I chose electricity because basically when I asked, the people said that in Spain there was more job in
Mhm.
electricity, right? And the problem is that I didn't really like it, right? I start studying it. It was, electricity is something that has been here for centuries, right? And I didn't like it. And then at the end of the degree, I had to do a final degree project, and also I was kind of interested in the PhD. But what I was really interested is in learning more. I really wanted to learn more, and I was kind of looking for avenues to learn more. And one thing that happened to me is that I went to a professor in electricity and I was asking her, like, is it worth it to do a PhD? And basically she said, no, it's not worth it. Like unless you want to teach at university, makes no sense to do a PhD. And I felt like I felt like, I mean, first of all, not a very good way of of getting people, right? And second of all, I don't really believed her. I mean, like, because I thought like knowing more is good. Like, and you can actually argue the same in engineering, right? Like you can say, well, maybe you don't have. Why do you want to do an engineering, or what do you want? What, right? So I was like, I think I really wanted to know more. I really wanted to get deeper into some area, and I was like, okay, I don't really believe this person. So I went to the Department of Robotics, and in the Department of Robotics, I started meeting people. They were kind of offering me projects, and I thought, wow, this is pretty cool. Like robotics is super interesting, right? In my university, they were building a humanoid robot, a full size humanoid robot that is one of the few. I think is the only university that was doing that in Spain, and like that was pretty interesting, right? Like I was a fan of Star Wars, and I thought, wow, like I love to be the guy who knows how to do the robot, how to make the robots of Star Wars, right? So then I started doing the projects, and I completely got in love with robotics, AI, machine learning. And I remember the first days they were, I started from nothing. I had no idea because, since I kind of moved from another field, I basically had no idea of anything related to robotics, to electronics, even to computer science. I knew how to program a little bit, but not that much. So basically, it's like I was doing a new degree from scratch. So I studied a lot. I worked a lot on that, like basically, almost 10, 12 hours a day. I was the first to arrive to the lab, the last to leave. I remember I was left when it was dark, and I entered when it was dark as well. And but at the end, I learned a lot. I really, really learned a lot. And then I started with my final degree project. They seemed to like me, and they offered me to do a PhD. So I did. In order for me to do a PhD, I had to do a master's in robotics first. So I did a master's, and then I did a PhD. And my PhD was about postural control of a human robot using control engineering and using a technique called learning from demonstration. Actually, it's funny because the technique that I use is mostly the same as the technique that ChatGPT is doing. Is this reinforcement learning from human feedback that basically is mixing reinforcement learning with learning from demonstration. So you have a reward function that you want to optimize, and you learn this reward function from a human, right? So same thing, like my advisors had this vision like 10 or maybe more, 12 years ago. And during that time, interestingly, I was kind of super eager to learn more. So I created my first startup that was a robotics club. And the robotics club was because we were going to the classes of the masters, and I personally thought that we were not learning fast enough. So we thought like, okay, so we are going to learn by ourselves. And basically, I convinced like half of the class to get start that with me. And the this is a non-profit a company, and it still exists at the university. It attracts a lot of people. We were actually one of the first people to bring 3D printers to Spain. So we created a massive community of people. We had like, I don't know, 20 or 30 3D printers, each of them with a name, and also we did many different robots. We did mobile robots. We did drones. That was very very complicated and actually a little bit dangerous. We did small humanoids that we went to challenges and kind of uh, places where we fight between each other.
Mhm.
We did mobile robots that kind of race between each other, and that was a very interesting experience. I think it was the first time that I had to run something by myself and actually collaborate with other people, and that was pretty interesting. And then
One question on robotics in general. I wanna stick to this topic for a bit. Like, what do you like? Two questions in one. What do you like so much with robotics? Like, why did you want to get into this subject? And the second question that might not be that obvious is, for all the listeners, is where does AI play a role in robotics? Because you've got all this hardware, but you've also got all this AI part. So can you
yeah,
touch a bit on those two topics?
yeah. So maybe one of the things that I like the most is the application of it, right? Like you go to your computer, you write some code, and after a while, you have a robot that moves, and that's something and solves a problem. So I'm always been a very practical guy. I'm the typical engineer. I'm an engineer. It's like I like to solve problems and make things work. So that's what I really loved. And I would say that in my degree, everything was very theoretical. And I was like, okay, yeah, I mean, like knowing the laws of physics, of Newton physics is good. But for example, in my PhD, I had to learn very deeply the Newtonian physics. It's actually like how different objects move, and how when there are contacts, how you calculate the forces and accelerations and inertias that are happening, right? So it's pretty nice, when at least for me, when you see the formulas of the Newton's equation of motion and in the blackboard, it, it's super interesting when you actually have these formulas embedded in code, and you see the robot moving like you want because you're following Newton's law. It's super interesting. So I really love that. I was in love with that. And then the connection between AI and robotics. That's kind of there are kind of two schools of thought. Like one, they say that AI is a part of robotics, and actually, some other people say it's like robotics is part of AI, and some people say they are completely different things, right? From my point of view, the robot, like when you create a robot, what you want to do is like a machine that can help you, right? And this machine has a brain, and it has arms, legs, and can move, interact, right? So the AI is doing the similar with the human. It's like your mind is like the brain, and the robot is all the body together with the brain. So the robot will be the same to the human, and your mind will be the same as the AI and the intelligence, right? That's the way I see it. Um,
And okay, so you mentioned at some point you worked on, was it something like imitation learning where they have to
Imitation learning,
learn
learning from
from the
imitation
human?
learning. Yeah, exactly. Yeah. So the original idea was that we and something very interesting that I learned with my advisors. When I was first having the first meetings with my advisors, um, first of all, one of the things that kind of changed my approach to life is, at some point he said, "What do you propose, Miguel?" And when you come from university, you are used that your teachers tells you what to do. They tell you what to do, right? They say, write this essay, or do this code, or pass this exam. It wasn't like that. He said, like, what do you propose? And I remember I told him, like, what do you mean? It's like, you are the professor, you are the super expert in the field. You should tell me what to do. And he was like, no. It's your thesis, it's your work. You need to propose something, and I'm here to guide you. Basically, his job was to you're going to propose something, and I'm going to tell, don't go this way because I went this way. I know this way is not profitable, it's not good for you. Instead, go this way. That is where you can create something interesting, right? And he has all the experience, and that's also something that happens to everyone, even when you work in a startup, when you work in a company. Like most of the time, it's not like you're not like in an environment where you have to do this. No, it's like, hey, you need to help. For example, in Microsoft, it's like, it's not that my bosses tell me, Miguel, you need to write this code, you need to do this. It's like, no, Miguel, the problem is that we need to increase revenue. How can we do it? And then it's like me saying, okay, I think we can go this way, or we can use this technique. And so it's more actually super similar to the experience that I had when I was doing my thesis, right? So I got in love. I got in love with that, and really interesting the how it changed my approach to life.
Why did it change your approach to life?
I think
In
it was,
which way?
yeah, in the sense that when when you're at school, it was like you just need to do what you're told, right? It's like, okay, and now it's like, no, you're alone. It's like you need to build your own future. You need to build your own solutions, right? So one of the one of the first mistakes I see in junior people, for example, at Microsoft, is that exactly they expect, they think they are still in university, right? It's like, it's like they are like, okay, so they're expecting you to tell you, okay, do this, do that. And kind of that's one of the journey of helping junior people, is actually realizing that they need to come up with the solutions by themselves. It's like you have so many ways of doing things, right? And then it's like, well, the sooner you learn that you need to produce the knowledge, you need to produce the solution. It's not like you just execute something that somebody else tells you. It's like the approach. All the teams that I've seen that are successful are groups of people like that. They are people that are creative and they come up with solutions, and there is a discussion whether it makes sense to go this way, it makes sense to go this other way. But at the end, is this person that actually is able to create something new and that is aligned with the objectives of the company.
Is this the kind of people that you're looking for at Microsoft, and people who take initiatives rather than just people who follow what to do? Or
Yeah, absolutely. I mean, like, one of the very interesting things at Microsoft, and I think this works in any tech company that they are innovative, is diversity. And diversity in all sense, diversity in terms of gender, in terms of languages, in terms of nationalities, but most of it in terms of ideas, and in terms of backgrounds as well. So there is a lot of evidence, scientific evidence, that proves that diverse teams work better than if you have a team that everybody's the same. So one thing that we tend to do, and it's very, very interesting, is in most of the teams that I've been working at Microsoft, we have people from very different backgrounds. So for example, when I joined Microsoft, I was the only one in robotics. And then there was another person from cognitive science, another person from bioengineering. And he was super, super interesting because, um, AI and robotics are, there are some AI solutions that are applied mostly in robotics that are not applied in commercial AI, right?
Mhm.
Um, I don't know. For example, I remember, yeah, just things like, for example, yeah, one thing that is very, very common in robotics is not very common in AI, is a closed loop system, control system. So in AI, what happens is that you create a machine learning model, and so you train your data, you create your machine learning model, and you score, right? And then sometimes what you do is you retrain the model with data, but it's an open loop system. A closed loop system, that is the kind of system that works in robotics, is that you have your model, you do a prediction, and then you measure where you are. You measure with your sensors, and then you close the loop and update, create this process to update everything, to improve the system, right? And this is something that in AI is very, very difficult to do. For example, one good case is recommendation systems. I work a lot in recommendation systems. So recommendation system by default is a closed loop system. You want to you have a set of users that come to your website, for example, and you personalize the experience, and you want this experience to update in real time. So this is something that it is very difficult to put to work, because the sensors that you need are, for example, the Google Analytics or all the analytics of your page, right? You need to, in real time, ingest this information into your model and update the model. So
Mm-hmm.
that's not very easy, you know. And this is something that in robotics is done every day. Like actually, all robots when they move, they are actually doing this process, you know. Like you have what you do is you have a desired trajectory. You want the robot to move some specific way, and due to, you know, maybe there are differences in the actuators, that the robot doesn't exactly move to the exact trajectory that you want, right?
Mm-hmm.
So you need to correct, right? And this is called contra engineering. So then all these processes that are super useful in robotics, like almost nobody knows about in AI. So, you know, having this diversity is super interesting. Like, and I talk about this robotics AI because this is, I know, but for example, people that come from biology, they also can provide a lot of value. People that come from neuroscience, or even a lot of people that are in AI, they come from software engineering. So, you know, maybe they are super good at
Mm-hmm.
creating products or making these things work. Whereas a lot of people in AI, they are typically more experts in math, and you know, like the math of the model, and they don't know that much how to really put this AI into production. So that's very
So, so,
interesting.
you, so you think that your robotics background helps you be a better data scientist at Microsoft?
Yeah, I think so. I think in my opinion, one thing that is not easy is actually to switch fields. And I mentor people that actually want to change their career from all the careers like software engineers to data science. And the way I don't think it's easy. First of all, because a lot of companies, they, you know, when they see a CV, they look at your experience, and you know, they say, I mean, like, you've been working 2 years or 3 years in software engineer, and then you want to work in data science, you don't have enough experience, right? Like, it's like, okay. And it's very common to, what they say, you know, like, judge the book by its cover. And one of the approaches that I kind of work with people that I'm mentoring is exactly the path that I followed when I changed from electrical engineering to robotics, and robotics from AI. And it was three ideas. The first idea is, um, understand what works today, what is useful today. So instead of learning the AI that was done in the past, learn the AI that is useful today. And that's something that happened to me when I was starting my PhD. That, you know, my advisors, they basically gave me a book, a really big book in control engineering, and they said, Miguel, read this book, and you know, start reading about, and this is kind of the first theory of control engineering, like typical book that, you know, it will take you from the beginning until the end, right? And I remember that another life lesson that I learned from my advisor is, you know, I read the book. It took me a long time to really understand it, and I went to my advisor and I said, okay, I think my proposal, you know, you wanted a proposal, so my proposal is that we need to use this technique. This is the technique that the book says is the best technique. So basically, you know, let's use that. And he said, no, no, no. Let me tell you why. Like, this technique it assumes that you have a model of the robot and a model of the environment, and you can operate with these two models. But in reality, the theoretical model of the robot is not like the real robot, and the model of the environment is not like the real environment. So even though in the book, in the math, it makes sense, in real life it doesn't make sense. So basically, what happened is that I realized that I lost 2 months of my life. It's like, okay, I read this book. It's like a very thick book, and I was like, very good. Like I had no idea how robotics. I'm already behind the rest of the folks, and I spent 2 months. I wasted 2 months, right? So then what I did is, okay. So instead of doing that, I'm going to start reading the things that are used today, and then I start, speaking with people like people that were more experienced. Like, okay, how do you practically how do you solve when you have this problem? And they start telling me, okay, use this technique, use that technique, right? And then also start reading papers, like getting information from many sources, right? And that's how we came up with this idea of learning from demonstration and reinforcement learning. And that was kind of pretty new. And since I had to do something, when you do a PhD, you need to propose something new. That really worked. And the interesting thing is that I spent like the first 6 months almost doing nothing. I didn't really produce anything. And when I changed the approach of going after the things that work first, I start producing a lot of value. So the way I teach people, particularly those that are changing their careers, is try to focus first on the things that in the AI solutions that work today, and do not start studying all these traditional methods that yeah, it will take you 6 months to get to the point where all the things that work today. And what I proved, and that's what a lot of people don't believe, is like, because people don't believe, like, I mean, if you want to learn NLP right now, is all about transformers, right? It's like you cannot learn NLP today like transformers if you don't know about logistic regression or supervisor machines, so stuff like that. And actually, you can't. You can. So my method is like, hey, start with transformers. Start with transformers, and because that's something that is useful today. And then if you don't understand something, then look up this part that you don't understand. And then it's kind of reversing. I call it reverse learning. It's kind of reversing the path. You start from the things that are useful, and whatever you don't understand, go back. And then what happens is eventually you're going to reverse the path. You're going to learn the original concepts as well. But you gain a lot of time, because from day one you are working with the things that are useful today. So if you go to an interview, and you want to start working in a project, you already have the useful knowledge, right? And maybe that comes a lot with one of the reasons why I really like robotics, because it was useful, right? So if you learn the AI that is useful today, then you are an advantage. So that's the first thing. And the second big point is, learn by doing. Is the practical learning path. So one of the things that happened to me is that I studied in many different universities. I studied in University of Madrid, a university in London, and in the States, right? And what I found is that a lot of the way that some countries, I think it actually comes from schools of thought, and I feel like Spain, Germany, Italy, France, maybe Poland, like continental engineering schools, they all start from the theory and they go to the practice. Whereas UK and US is the opposite. They start with practical knowledge and then they go to the theory. And I experienced both strategies. And I found that it is, at least for me, and I prove this with many other people, it is better to start with something practical and then go to the theory. So that's the second idea that I share, is like, don't just do. A lot of people, they just read books or just watch
Mhm.
YouTube videos. That's not enough. Like, create a project. So if you're a software engineer that wants to get into AI, create an solution, like your project, your solve a business problem with AI, create your GitHub repo, and start coding and start kind of, you know, trying to see how you solve this problem. And I think that's a very good approach, because you really get the experience that, you might not get, you might not have the experience in when you were doing software engineering, but well, you are creating the experience by yourself and
Mhm.
solving this problem. And the idea is, if you go deep enough, and you have a problem that is difficult, and you really go into, and you put there the AI that is useful today, then you have a very good profile. Even though you haven't worked in AI before, maybe, well, you really know about the AI that is useful today, and you can prove it. You can say, hey, look, here's my code, here's my project, and I have this website that recommend wines. I don't know, for example, right? And you can see it, and this is how I did it, and these are all the models that I tried, and I tried this model because this is the state of the art, and then I compare that with something that maybe is not deep learning, is faster, but is not as accurate as deep learning. So I feel like this approach is really powerful.
Yeah, I want to say a few things on what you shared because you shared many super interesting things. I really like your reverse learning approach of starting with the state of the art and working backwards. Like when you don't understand something, you dig into it and finally you end up understanding the basics because you kind of need to understand the basics if you really want to understand how a transformer works, for example. One issue, or maybe not issue, but one kind of negative point I can see with this is it might be more complicated to jump straight into learning transformers than starting with linear regression, which I guess is a reason why school starts with like linear regression and things like that so that you can get used to the process. It's the same thing in the end. You need to find the optimal weights, but it's much easier to learn this with linear regression than with a transformers. But I agree with you that if you start with the transformers, you might gain time because you directly try to learn what's actually used
Yeah.
today.
No, absolutely. It is. I think it's something that I don't see anyone else saying this approach, and and that's not the typical approach, right? Like, the typical approach is you get to any book in machine learning, and you start with linear regression, and then logistic regression, and then supervised machines, and right. But there are not that many occasions where you will use a supervised machine in a real problem, right? So the thing is, for example, if you're doing, just to put a very practical example, if you're doing machine learning with tabular data, like the general data set, right? What 90% of the people do is they start with linear regression and then logistic regression. What the real experts do is they don't start with that. They start with boosted trees. Everybody
XG
starts like
boost.
XGBoost, LightGBM, like a lot of the folks that are doing Kaggle competitions, they don't do linear regression. They don't do support with the machines. They do XGBoost. They do boosted trees. All of these, right? Now, you can understanding gray and boosted trees. Yeah, definitely is more difficult than logistic regression, but it's not that much difficult, right? But the thing is, from the practical point of view, at the end is like, if you want to work in AI, you need to solve a business problem with AI, and that's another very interesting key point. Is like, a lot of people, when they go to this company, they think that they are getting paid to to do machine learning, to do machine learning models, and no, that's a mistake. You are being paid because you need to solve a business problem with AI. That's very, very, very different. It's first, the most important thing is you need to solve the problem. It's not like
Mm-hmm.
if you use one model or 10 models, or if you don't use machine learning and you use SQL query, they don't. I mean, it doesn't matter. Like the important thing is you need to help the business. Otherwise, we're all out of business, right? So um, if you consider this perspective and you say, okay, I work in this company, I work in this startup, I work in this big tech because I'm serving my customers. I'm solving this business problem to help them, right? So okay, I need to figure out what are the best tools, the tools that people, the advanced people are using today. So it's like, and then if everybody time is limited, right? So I will argue that it's more useful and it's more beneficial for anyone wanting to get into AI to understand transformers, to understand boosted trees, than to understand linear regression. If you have to choose, it's actually more useful, right? Now, a lot of people argue that, I mean, it's impossible, right? You need to go through all the, and I don't agree with that.
Mm-hmm.
And the example I put is, um, maybe I need to find a better example, but one of the oldest jobs in history is war. Like that's one of the oldest jobs, right? And then you can say, okay, so imagine that you need to get, you want to get to that job, right? And then you say, okay, so I'm going to get to that job, and then I'm going to start the book, and I'm going to say, okay, so the best general of history is Alexander the Great, or maybe, I don't know, maybe it's Caesar, or maybe it's Napoleon, I don't know, whoever it is. And then you start studying Alexander the Great with the elephants, and he conquered whatever, or Caesar with the legions, or Napoleon, whoever. Makes no sense. It makes no sense. Like you're studying history of war. What you need to do is you need to learn how to fight today. Maybe today you need to learn drones, or maybe you need to learn cybersecurity, but you don't need to learn how to
Mm-hmm.
fight with elephants, right? So that's in kind of a different context, right? Because AI is
Yeah.
very, very short, but that's what people are doing really. They are learning. They are not learning AI that is useful. They are learning the history of AI until they reach the point where they get to AI is useful. And then what happens, what in practice what happens is that a lot of people don't get to the AI that is useful. And this is why I'm teaching this concept, because I've been doing a lot of interviews at Microsoft, and a lot of, like, 80 or 90% of the people that come to me, they don't know useful AI. And then everybody knows about register regression. Everybody knows about linear regression. Everybody. But it's like, yeah, but I mean, if I hire you, then I need to teach you useful AI. So if you come with useful AI already, then you are going to be a better teammate for, you're going to produce a better output in my team. So I don't think, I think that the way people do interviews is completely messed up. They don't really, and maybe it's because nobody thought about it. Maybe it's because we are used to do it this way. But a lot of the time, people ask questions that are not related with the business. So it's like they are doing exams. They are, okay, so explain to me what is linear regression and what are the conditions for linear regression. And you're not going to use linear regression. Like, you're not. So why if you want to get a candidate, why do you ask for linear regression? You should ask, like, okay, if I have this problem, how would you solve this problem that I have today, right?
Yeah, maybe it's because of the interview process then, because in so many interviews they would ask the basics, like what is a support vector machine, or yeah, can you prove this, or I don't know, things that are very, very basic and simple. And so people who want to get into the field, they think they need to know all this basic stuff really well first, which I agree with you is kind of a bit, as long as you can use the algorithm and make it useful, you don't really need to know all the details behind things that were useful 10 years ago. But because interviewers still ask this for some reason, people want to learn it, and they lose time, and they might not get into Microsoft, from what I understand, because they don't know the latest techniques.
Not just Microsoft. I'm talking more in general, right? Like, at the end is like, wherever you go, the more useful you are in your job, the higher the recognition, right? So at the end, it's like, hey, if you like, let's say if you work in a startup, for example, if you work in a startup, one of the things that happen is that you need to typically wear a lot of hats. So you need to, you are hired as a, I don't know, machine learning engineer in a startup. You're going to be a machine learning engineer, data engineer, software engineer. You need to be a speaker. You need to write essays. You need to be marketer, right? So what I will suggest is something that I think is really obvious. Like, do the interview that is consistent with the job, right? And a lot of times what happens, and people get super frustrated, is that a lot of companies, they promote a data scientist work, right? And you're supposed to work doing machine learning, building machine learning models, iterating, and then you go to the job and it's actually a software engineer or a data engineer job, right? Where you just need to build pipelines. Or maybe you need to operationalize machine learning models, which is not definitely building the machine learning models. You have the model and you need to put the model in a Kubernetes or whatever, right? And then people get super frustrated because it's like, okay, I thought I was going to work building machine learning and I'm doing software engineering and I don't like it.
Two previous things that you mentioned, actually, that I wanted to go back is, again, you mentioned the second way to learn is doing a project, and I really like this approach as well. I think I actually plan to write a post on this week on LinkedIn, because I think we can even use your reverse learning approach for projects. Like, even if you don't know much, start with a project, and then if you don't know something, learn the theory in order to do that. That's how I learned Python and the basics of deep learning. Like, I didn't know much about Python, but I had my research thesis. I had to do it. And so I had to learn pandas. I had to learn how to process a data frame. And so even if you just start with a project, obviously you need like the basics, like you need to know how to code. But as soon as you've got those basic things, get a project, and what you need to learn for this project, learn it on the spot. Don't try to learn 10 million things before starting a project, because that's not going to be that useful. So I fully agree with you on this.
One very interesting point of view on that is a lot of people that are in our space, right? They are in technology, they are in computing. They are good at fixing things. And something that happened to me, I remember in my house, I was always the fixer. If the TV was not working, I was, Miguel, TV was not working. Can you fix it? Mm-hmm. And I remember like many times, like, my sister or my mother, they were like, Miguel, do you know how to fix the TV? And I was like, I have no idea. And it's like, I always end up fixing the TV, right? And the way I do it is I start touching the buttons, like, okay, it's a menu, and you start touching the buttons and you end up fixing it. And like 99% of the time, I never look at the manual. And this is something that a lot of people in our field are technical, they do naturally, right? So it's actually the same approach. For example, one thing that I did, there is in Microsoft, there is a gradient boosted tree library called IGBM. There is also XGBoost, that's from University of Washington. And like 6 years ago or something like that, these libraries were pretty new back then, and I wanted to learn about them. So at that point in my career, in my team, we were doing blogs. We're doing blog posts to, basically the idea was that we had to do blog posts about something running on Azure. And then I wanted to learn about these libraries. So I talked to my managers and I said, hey, I would like to make a comparison between LightDBM and XGBoost. And that was the excuse because I really wanted to learn about a gradient boosted trees. So I basically what I had to do is, first of all, is okay, what are the gradient boosted trees? So I had to read papers, and then it's like, okay, so now we're going to solve. I think we solved like 10 different machine learning problems with different data sets. Some of them were classification, some of them were regression, and we did a post comparing the both libraries. And this was kind of 5 years ago, something like that. This post went viral, and also it was really good because one of the perks of working at Microsoft is sometimes the people that you work with. So one of the authors of LightGBM was at Microsoft, kind of the main author. So I actually sent him an email. The guy's called Duolin, and we kind of became friends from there. And then we said, look, Duolin, like we are trying to compare XGBoost and LightGBM, and it's actually very difficult because we don't really understand the libraries and the parameters. Like LightGBM has, I don't know, 130 parameters. So basically, we talked to him. It's like, okay, can you help us do apples to apples comparison? Because we didn't want to, and also as Microsoft, we didn't want to go there and say, oh, LightGBM works better, and you are not really doing a thoughtful comparison. So it's very, very important to do a thoughtful comparison, and we're going to publish the code. And also, we talked to the author of XGBoost and said, hey, look, before publishing, we're doing this. I want you to try to see if it makes sense, if there is something, and that's actually how we learn LightGBM, and it's a very, very practical way of learning. It's very, very powerful.
Yeah, no, completely agree with you. Like projects is always a great thing. I kind of went on a tangent, but a big tangent. We discussed many topics. I want to close the robotics chapter before moving on to Microsoft. And so my last question is, you got into the field like in the year 2000, something like that. I think I saw a video on YouTube in 2009 of you showing a robot dancing. So now we're in 2023, 10, 20, 15 years after this. I'm wondering, where do you see the field going over the next 5 to 10 years in the robotic space, especially robotics and AI? Like, where do you see this going in the future? Am I gonna have a robot at home every day doing the dishes for me, or where do you see this going?
That's the objective. That's what I got. That's what I got into robotics. There was a video. There was a company called Willow Garage that, in my opinion, it has the best robotics video ever. And there is this guy saying, sometimes you're coding and you want a beer, but you don't want to stop coding. So no, like we'll solve that problem. And then basically it's like the guy has a software that it tells a robot to grab a beer from the fridge and bring back the beer. And I thought that was amazing. Like I love to do that. Like I'm here talking. Imagine I'm here talking with you, and I have my robot, and it's like C3PO. I need a beer. And then I'm still talking to you, and I have my beer or my coffee or whatever, right? And from the advanced point of view, I wrote up a post on my blog about what is the difference between the progress of robotics and the progress in AI. And there is a massive difference. Like you see that AI has progressed a lot. Like, we have ChatGPT, we have Stable Diffusion, like massive advances, right? Still, we don't have robots around us. And in my opinion, the reason why we AI has uh, is really really developed is because there was it is a more open field. So people, universities started to share the code, and then another very interesting thing is that big tech invested a lot of money
Mm-hmm.
in these areas, and they didn't take the code for themselves. So there was a massive change of paradigm between, I don't know, maybe the early 2000s until now, where big companies like Apple, Microsoft, all these guys, they were very close. Like every all the research that they did, it was completely you cannot, they were not sharing that knowledge. And then what happened is, what they learned is that, hey, if everybody shared the code, it's like the prisoner dilemma. If everybody shared the code, then all the ecosystem improves faster. So that's the massive, I think that's the massive learning of the last 50 years of technology, big companies. And they said, well, uh, Facebook, now Meta, Google, Microsoft, Amazon, what we're going to do is we're going to share all the code. We're going to do the research, all the research, and we're going to share it with everybody for free. And the consequence of that is that suddenly the field skyrockets, and it's very good for everybody. It's good for Microsoft, it's good for Google, it's good for everybody, because everybody has, it's kind of, we are uh, uh, going faster into the future, right? Now, that didn't happen in robotics. That didn't happen in
Mm-hmm.
robotics. In robotics, in the early first decade of the 2000, uh, the more advanced robots were Japanese robots. There was this Asimo robot from Honda. There was another one that it wasn't as famous outside, but it was super famous in the robotics community. Is RPT2, that from the AIST. The AIST is like the big research institution in Japan. It's like a massive research institution that they have all the sciences. They have biology, all
Mm-hmm.
kinds of engineering, and these were robots that were really really good, but they were not sharing. Like, everything was a black box, so nobody knew how these robots were working. And then obviously we have Boston Dynamics, and Boston Dynamics is the same thing. Boston Dynamics, it was from a couple of MIT professors that they are around 20, they were 20 years farther away from the rest of the robotics community. They were able to, they solved the stability problem that everybody else were not able to solve. These guys solved the stability problem, and they have these robots that are absolutely amazing. They jump,
Amazing.
right now. But even now, these all these technologies is closed. You don't have, you cannot replicate by yourself
Mm-hmm.
any of these robots. Only they know how to do it. No other company know how to do it, right? So now what is happening is that the next thing is they need to prove that these robot, like spot robot and all these robots, can be really good companions and can really solve problems for humans, and that's what they're trying to do, right? But that's, like, the reason, in my opinion, the reason why the AI is much more advanced than robotics is just because of is the openness. It's like,
Mm-hmm.
if you open, it's like counterintuitive, right? It's like, you don't, like, a lot of companies say, I don't want to share my secrets, because all the companies can come. But then if you open your secrets, what happens is that everybody improves. And if you are in the front line, which is exactly what happened to Microsoft, to Google, to Meta, to Amazon, they are already in the front line. So they are going to be the first to get the benefit, right? So that's, I
Mm-hmm.
think that's the amazing thing that is happening right now.
So let's move on to Microsoft now. And yeah, that's actually a very interesting point, that comparing openness vs closed systems. And yeah, we noticed that with openness, we progress much faster. So maybe this would happen maybe they will realize in a couple of years that they
Maybe
actually need to.
maybe they listen to this podcast and they say, "Wow, the idea is good. Let's do it."
Exactly. We'll send the recording to Boston Dynamics. Let's see what they
All
think.
right,
Um, but yeah, let's move on to Microsoft now. You've been at Microsoft for around what, 6, 7 years.
yeah,
So
yeah,
yeah, tell me a bit what happened when you joined. What are you doing
yeah,
now? How is it to be a lead data scientist at Microsoft? How is life?
yeah. No, it's really nice. I remember when I joined Microsoft, I was working in Spain, and they book a flight from Madrid to London, and I had the interview there, and it was an interview of 4 hours, and it was like, and I remember actually that four people came from the US, two from Redmond, two from Boston, and I thought like the interview was good, but I mean, I thought I don't think they're going to get me, right. But I mean, I got a trip for free to London. It was a good experience. Like, I think it was good. And then they come back and say, "Yeah, Miguel, we would like to hire you." And I was like, "What, really?" And actually, I told my manager once that I had a really tough negotiation with my wife and my family, because we actually had to move to another country. And I mean, for people that live in the US, it's very common for them to kind of move countries, to move places, right? Whereas in Spain, it's kind of, like, you're born in Madrid, like, more likely you work in Madrid all your life, right? And you just go to places to visit, but not to work, right? And it was a tough decision because my wife was pregnant, and she was pregnant, and it was like, wow, like, okay, so if we move there, we're going to have the baby there. And my family was not there, my mother, my father-in-law, right? Like, and we don't have help, and we don't know how a baby works. So it was a very tough situation. We end up taking the chance, and I think it was really, really interesting. And just going to the countries, meeting people from different cultures, working in a big tech like Microsoft is super exciting. You see, um, there is one thing that, when you join the company, there is a video from Satya that kind of welcomes you, like, welcome to Microsoft, and it kind of also obviously explains to you a little bit the story of Microsoft. I thought actually they could explain it better, because I mean, the story of Microsoft is super interesting. But there is one thing that I remember, like fire, and I think they changed it. Like, new people that join Microsoft, they don't have it right now. So I remember Satya said, at Microsoft, we have some of the smartest people in the world. And I thought, wow, that's true. It's true. They have it. They have it, right? And then the next thing I thought is, I'm going to meet these guys. I'm going to meet these guys. And one of the things that I say to people I'm mentoring, and people in my team, is like, take advantage of that. Like, you actually, Microsoft, you have the email, and you have the teams. You can talk to some of the smartest people in the world, and these are they have massive experience. They know a lot. Like, we have, I mean, if you like Python, we have Guido. We have the creator of Guido at Microsoft. The other day, I talked to a person called Eric Gama. Eric Gama is one of the creators of JUnit, like all this theory of developing, starting from doing the test, and then creating the work. That's from this guy. And he was advising me on how to create a test of one of the repositories that we have, that's called recommenders. and we got the feedback from the father of testing, you know. And I think that's one of the best things at Microsoft. You actually have access to these people, and you know, you talk to them and they give you. So I feel like you learn faster. You learn faster than if you were in another place. So for my, that's the most valuable thing that I have at Microsoft.
What are the top one or two things you learned from your conversations with smart people at Microsoft?
Uh, that's a very good question. I I think that one of the big lessons, and that's let me tell you this one. In Microsoft, we have a review every 6 months, and we call it Connect. And a Connect is one of the changes that Satya Nadella introduced when he took over is this concept of growth mindset versus fixed mindset. So a growth mindset is kind of the, instead he talks about, instead of the know it all, we want to, each of us want to be the learn it all. So it's very important when you do the review, what have you learned, and there is a section in your Connect that you need to say, okay, what have you learned, what you could have done differently, right? So one of the biggest lessons that I learned, and maybe this is valuable, particularly for people that are in tech. Normally, these people are smart. They know how to do things for themselves. They don't need help. I know how to fix it. One of the best things that I learned is that it's good to get help. It's good to get help. And also related to that is that your managers and many times your colleagues, they are there to help you. So it's actually sometimes it's their job. It's like their job. And then if you don't tell them that you have this problem, they cannot help you because we can read minds yet. So what happened is that I like when you go to a company, you realize that the biggest problems are always people problems. Like is uh, machines are easy, people are difficult, right? That's one thing that you very quickly learn. So I was having a problem with a colleague that is kind of difficult person, and I tried to solve this problem by myself. I said, okay, I'm going to try this. I'm going to try that. I'm going to, and then at some point it was like I talked to my manager and I said, look, I try to solve this problem. Like I said a typical sentence like, I want to come to you with problems. I want to come to you with solutions. And he told me, well, my job is to help you. So you are actually taking my job out. Like, and in basically 1 week, he solved the problem that I was not able to solve in 2 months. So that was a very important learning for me, and I see that a lot. I see that a lot even at Microsoft and everywhere, right? Like you don't want to bother, and sometimes it's because you don't want to bother the other person, but sometimes there is something that you want to solve, and it might take you 1 week to solve this thing, and you can spend 10 minutes with another person, and they solve this problem. And something very interesting, I noticed that this is a learning that salespeople know better, because a lot of salespeople come to me like, for example, I have worked a lot while at Microsoft in recommendation systems. So many people, so many salespeople in technical sales come to me and say, Miguel, can you help me with this customer? How would you approach this? What can we tell the customer to actually help them to solve their business problem, their recommendation system problem? Very few, very few technical people come to me to ask for feedback. And I think is, in 10 minutes I can solve 90% of the problems that these people have. And maybe they take 1 to 3 months, and I can solve their problem in 1 week. So my, my feedback is ask for help. Ask for help.
Yeah, that's a very good point. I actually wrote a LinkedIn post where I mentioned some of this. I realized this when I started. I think one issue is, again, at school, you're used to, you need to solve the problem on your own. Like, you
Exactly.
need to do the homework yourself. You cannot ask for your classmate to help you. And so you're in this mindset of, oh, I need to solve it myself. So this is my project in my new company. I need to solve this problem myself. That's one thing. The other thing is also, I guess, a bit of ego. Like, you kind of want to show people that you did it on your own and that you
No.
didn't ask for any help. But I actually think in industry, there is no point spending 2 weeks on a problem if you can ask your manager or a colleague to help you and do it in 10 minutes. And that's something that I agree with you, not enough people do. And asking for help is actually a very important skill to develop, because asking for help will make you more efficient at
Yeah.
your work.
And also it's also rooted in this concept of growth mindset. So when you ask for help, the first thing you need to realize is that you don't know. So it's precisely what you said. It's an ego thing. It's like, I mean, I want to look the smartest guy in the room, but if you ask for help, it's like you need to be humble enough to realize that you don't know. And I don't know. This is something that it was. I don't know. It's because I was always, or most of the time, surrounded by people that were far smarter than me, particularly when I started my degree. So it was obvious that they were smarter than me. So it was I was not ashamed of asking for and asking questions because they were so high that it was like, I mean, like, and and I think that's one of the biggest problems. The other problem, and this is more related, this is something particularly for people that are in AI and are technical, is that people don't understand that what their job is. Their job is not to write a machine learning model and write code. Their job is to solve a business problem. And that's the this is something that it is very evident, the as you are growing in your career, as you're maturing and you're getting to senior principal, etc., that at the end of the day is, hey, you need to be aware, and that word is super important, this awareness of what is happening in your organization. And you need to have the context of different
Hmm.
teams, and you need to understand that you're not there to just import TensorFlow as TF. No, you need to solve a problem, and you need to do as best as you can, right? Like, and it's like, sometimes solving the problem, maybe you don't need a machine learning solution, particularly because it's like, you obviously, if you have a hammer, everything looks like a nail, right? If you are in machine learning, you have every problem can be solved with machine learning, but sometimes you don't need machine learning. Maybe a SQL query is actually faster and better, right? So a lot of the mistakes I see is that they are not starting with this mindset of helping the customer and solving this problem. One, and this is very evident when people are coding. One of the most difficult things at Microsoft, at Google, at any company, is making people work together. That's super difficult. That's incredibly difficult because everybody's good at working alone. Everybody's good.
Hmm.
You don't have Nobody's telling you how to write your Python code, right? But you can go to a point. If you really want to go far, you need a group of people, and that's where the problems start to arise, because you're like, no, here we should do a class. No, here we should do a function. And then people start arguing like, no, because classes, no, because, and then let's do a vote. And then the approach that I would talk at my team is like realizing, who are you serving? So you're not doing this code for you. You're not doing this code for you. You are doing this code to solve a business problem, to serve your customers, right? So one thing that was very, very effective is we completely changed the discourse on, instead of saying, okay, what do you think, what do you think, what do you think we should do the code? Instead, we say, what do you think it will be most valuable for our customer? And this is an example of how we completely changed the way we coded in recommenders in the repository. Instead of thinking, okay, so how would we build this machine learning model, or how will you will code this thing? We will think, okay, our user, the people that are using recommenders, what will be very useful for them? And one, for example, one thing that we did is we said, okay, a lot of people want to learn about recommendation systems. Well, one thing that we can do is we can create notebooks with examples that explains to you each of the algorithms. It's like, okay, so here's the algorithm. It works like this. It is good in this situation, not as good in this other situation. And then you have, using this data set, how it works. And then we have, okay, so we have all the phases like data prep, machine learning modeling, and sometimes even deployment. And that was very useful to people, because people kind of learn how to do recommendation system. And for us, it was really good, because instead of arguing whether we should do this, we should do that, we were thinking, okay, what can we do to serve our customers to make their experience as easy and as beneficial as possible, right?
Can you just briefly give an overview of your current role leading the personalization team? What does this mean, and what do you currently do at Microsoft?
Yeah, so one of the things that I kind of moved a little bit over the years, and so maybe I can tell you a little bit my trajectory instead of exactly what I'm doing today. So I started as what is called customer engineering, and customer engineers are people that help go to customers, and they help solve their business problems with AI and with Azure, right? So basically, we will go to some customers that were already using Azure. They already have some kind of deal with Microsoft and Azure, and sometimes they want to solve a specific problem. We work in NLP problems, in computer vision, in recommendation systems problems, and at the end it's like, okay, we are going to spend all this money in compute, in databases, and we went there to help the engineers to build AI solutions, right? And then this is one of the a pretty common role at Microsoft. And then another common role is what it is called product development. Product development is any AI feature that you will see in some of the products at Microsoft, right? Like, and then I was working in that area as well, creating products. In this case, were products for different industries. It was retail, gaming. Uh, some other teams were working on other areas like energy, logistics, and at the end is you create an internal product that has an AI component, and you solve a business problem for our customers.
Okay, and this is what you're working on today, then?
Yeah.
Okay, yeah, great. So let's finish with one advice. If you just had one advice for someone to progress in their career, what would it be? Just one advice.
One advice for someone progressing in their career. In my opinion, one of the best things you can do if you want to progress in your career is get a mentor. Like, actually, I had a process that I followed that is called the Guide 100. This is a process that comes from another idea that is called the Dream 100. This is kind of a way in sales to kind of focus on 100 dream customers, right? And just focus on that and try to be the best for just these just 100. So I took the idea and said, okay, maybe you can do that with mentors. And a mentor, like the typical understanding of a mentor, is someone that you work with them, and a lot of the times, for example, it could be your manager, could be a senior person in your organization that maybe is not in your organization, and somehow, well, you kind of develop your career, you kind of extract information from them. So the guide 100 is that you kind of evolve that idea and not only work with people that you have contact, you also get learning from people that you don't have contact with. And then what you do is you take this person that is one of your dream 100s and learn everything about them. Everything. It's like, for example, one of my dream 100 is Satya Nadella. Satya is not my boss, and I don't have many opportunities, almost no opportunity to talk to him one to one. So what I do is I learn everything about him. I know his trajectory. I know about his family. I know that he likes like sports that he likes. I know the way he thinks about the company. So he's a lot, for example, into empathy, and empathy in the sense that we need to understand. He says the unmet and articulated needs of our customers to be able to serve them. Okay, and that's where innovation happens, when we have this empathy of understanding our customers, right? And he's super interested in growth mindset. So if he has a book, you read the book. If he for example, just to give you the example of Sadia, he was influenced a lot by a book called Mindset. So you go and buy the book and read a mindset book, and so you understand the content. So is this idea of really understanding the life of and the way of thought of a person, to learn from them, and you do that for a group of people. So some of these people can be mentors, or can be people that you learn from, but you really have a really specific way of kind of getting learning from them. Because one of the things that I learned is that the best way of learning something is from others. Mm-hmm. That's the best way, the quickest way to learn something, and that's actually why we go to school. That's nobody get the kid and put it in a room, right? It's like, okay, learn math. No, we go to school and we learn from others. So humans learn from others very well. So if I had one advice for your audience, is get a mentor and really get serious about improving yourself from other people.
Well, Miguel, thanks a lot. That's a great way to finish the episode. So yeah, thanks a lot. It was great to learn and chat with you. Have a great day and hope to catch up very soon.
Yeah, thank you, Neil. Thank you.
Bye bye.